Okay, I'll start this demonstration of the StemThief. So you get a spot where you can see the monitor over here, and I am recording this, so I'll post this to YouTube or somewhere else, and just make sure I get your name afterwards, and I'll send you a link and a copy to that. So the idea here is that this test stand is our small version of a housing. So we have the stem that comes up through here, the stem nut, and then the stem protector with thread into this housing. So you would remove the stem protector, substitute this adapter nut, which has an outside thread to match the housing, a pipe thread, and then inside has a straight thread. And then this is the relubricator, which has an outside straight thread, has an O-ring inside set into a groove, and we can then screw this down on top to meet the top of the nut. So I've done it a few times here, and you can see where the imprint, the black circle imprint of the O-ring is. So it's narrow enough to fit inside the keeper nut, I don't know what you would call it, but the nut that holds the stem nut in place. So you don't have to loosen that or remove that. That can stay in place. And in place of this stem nut, I built a clear version. So what you're looking at here is a clear replica of the stem nut, just so we can show what happens when we relubricate. So you don't really have to tighten down this adapter. It's merely meant to be in place to give a point to load this down, but I'll advance this down. And there's a little window here, and you can maybe see in that window as this comes down and makes up with the top of the stem nut. Feel free to ask questions while I'm doing this if you have any. All right, so I bring this down in contact. I also have a spanner wrench, and you can just kind of snug it up a little bit if necessary. Just a standard grease gun. Not everybody realizes, but you can generate quite a bit of pressure from a standard grease gun, several thousand psi. So I'll start to add some grease. Now at first it's fairly easy because what I'm doing is I'm filling the space. This particular one I've made is got about a 6-inch bore to accommodate that up to that much stem sticking up. So initially you're just going to be kind of loading the grease up into that space, but eventually you'll feel some back pressure, and that's kind of the sign that you're starting to send grease down into the stem nut area. I'm starting to feel a little bit of back pressure. And what I'm going to do is really slow down. You see some movement? And of course, the further you go down, the more back pressure you're going to be building. So you want to do this very slowly and kind of pause. Unlike a hydraulic fluid where you apply pressure and it's kind of equal throughout the whole body of fluid, grease behaves as what we call a non-Newtonian fluid. So there's actually a time that pressure has to dissipate through the body of the fluid. When I've done this for, one thing you'll notice is it'll go into the space at the top of the crown of the stem first, and then behind that you'll see it go into the kind of valley of the thread as well. Kind of tracks it down. Now I'm probably going a little slower than I have to because this is still plastic, and when I was doing it in the lab, that plastic will actually deflect a little bit, and I had it blow out past the O-ring. I don't expect that to be a problem when you're using it with the metal version, but Again, it makes sense just to go slowly as you're pumping this to allow that grease to dissipate. Now, you'll see it's starting to come out into the counterboard section at the bottom of the nut. And now's where it'll take a lot of grease to fill that section up. Now, you may decide you want that to happen. You want to dissipate. You want to displace all the old grease. You want to fill that up with fresh grease, so that's almost like a reservoir to re-lubricate the threads as they go up and down. The other thing that becomes possible if we displace the old grease is that we can capture it for analysis. And so we have kits available. The kits include a spatula that allows you to kind of grab that grease. What I would suggest, and in one of the videos that I placed for this, I suggest that you use one end of the spatula to kind of dig away the first grease that comes out. Typically it'll have some dirt on it and so forth. Kind of get that away and then get the grease behind it that's coming out that should be more representative of what's going on inside the nut. So we'll look, our analysis looks in 4 areas. We look at the wear that's being displaced, the wear particles that are there, any contaminants that might be present, moisture, dirt, even evidence of other greases or other materials that may have been used there. We'll also look at the consistency of the grease, so if the grease is hardening or softening in service. And so we have a test that's a dye extrusion test where we squeeze the grease out through a small orifice, measure the back pressure that's required to do that relative to the new fresh grease, and we call that that's a measure of this consistency. We refer to it as a dye extrusion index. And then we can also look at the antioxidants. So your greases are typically formulated with antioxidants, and if you can establish what the level of antioxidants are in the new grease, you can look over a period of time and say how much residual antioxidants are present as a function of how rapidly is that grease degrading due to the aging process, the working of the grease, and especially the heat that it may be subjected to in a particular application.
It's a very dirty application. High chemicals, if you leave that in place, have like a pressure limiter.
I would not suggest it because my concern is about like a hydraulic lock potential, and I thought maybe we could come up with a pressure relief on there, but then if you were to feel how much pressure I have to put on this handle, it actually generates quite a bit of pressure. So I don't know how I'd get that level where it would be high enough relief setting that it wouldn't blow as I'm trying to put grease in, yet it would blow selectively when the stem would start to go up and down. So I would say for now, no. I would just use this while the valve is electrically blocked, tagged out, so that you don't get any position move. Install it, run the grease through, then remove it and put it back in service. As far as this is a tool that could be reused. So if you have this is one that was sized for an SMB0. So if you had a number of valves in kind of the same dimensions and so forth, you can make one and reuse it for those applications. Larger valves or smaller valves may need different dimensions to optimize the application. So on StemThief.com we have an input form where you can give us your dimensions of a target application you have, and it's really just time materials. We just price it out because we custom make them based on the dimensions of your application. I can't see on that side. Is any coming out the bottom yet?
Yeah.
Okay.
How effective is flushing out part grease?
Okay, so after last year, that was a question. So I went back to the lab and I took this nut and the stem that we had and greased them up with long life and put them in an oven. I think on here I actually have I did it at 215 Celsius for 14 hours. Yeah, it's over 400 degrees Fahrenheit for 14 hours to really bake that grease on. And then attach this and pump the grease. And there was more back pressure than I experienced, obviously, from a clean setup. But I was able to re-lubricate that, push the old grease out. And actually the area of the stem where the nut was engaged looked pretty good. But the areas on either side that were exposed, the heat kind of drove the grease away, left a thin film, and that film oxidized to a hard varnish on those areas. So we were able to reestablish the path to put a new layer of lubricant there. But no, we did not restore. It's not a restoration process. However, the grease that came out, we analyzed it, and it was very clear that there was evidence of oxidized greases in the sample that we took. So that would then nominate that particular valve for a future operation to remove it and have to do retreat the stem to get that cleaned off. But in the meantime, this would be a non-outage, non-service interruption way of reestablishing the grease and improving it from where it is. It's a good question.
Just a question for the guys in the station. If somebody is getting this stem for a project and wants to operate, how long is it? You have this as an operating valve, it's like a valve, how is it operating?
For this demo, because I have this stand, it's hard to get up inside the nut, and I think the accessibility there, I guess, depends on how much room there is to the packing. So what I'm going to have to do, and what you may have to do, is to have enough grease come out that it's actually below the bottom of the nut so that you can kind of get in there and dig it out. So I'm going to pump a little more in here and see if I can get it to come out the bottom and show you how I take a sample. One of the things I've thought about doing is outfitting the grease gun with a pressure gauge and giving some guidance to the guys in the field. Because I'm just kind of using my experience not to overpressurize this. You can probably put some value in, like, don't pump so fast that you exceed a certain PSI value to kind of control that process a little bit. Okay. Now you can see some of it coming out on the bare stem. So here's the kit. It comes sealed. It has a Ziploc. And there is a syringe and the grease thief. So I take the syringe and open it up. I talked about using the fat end to kind of dig away the first dirty grease that comes out. And then I would just take this and kind of paint it down into the hole. Until I have enough, I need about that much. Put this on the end, pump it in here, and now that's the sample that I'll take and analyze. Now internally you may decide to do this just kind of a visual indication. You might squeeze it out on a white paper and look for debris or what have you. Or there's analysis that can be done to do the test that I talked about. So, any questions? Thanks, guys. If I don't have your name already, just jot it down for me and I'll send you a link to a copy of the video and some follow-up information. Thanks.